student at home, you are welcome to another wonderful edition of School on Air. And today in chemistry, we'll be talking about electrolysis. In chemistry now, we look at what we refer to as electrolytes. We're talking about liquids that can conduct electricity. We also talk about liquids that will not conduct electricity, which we refer to as the non-electrolyte. So today in electrolysis now, we are going to look at the meaning of the word electrolysis, the meaning of the word electrolyte, the meaning of the word non-electrolyte, and those substances or compounds that can be classified as electrolytes and non-electrolytes. To start with now, what is electrolysis? Electrolysis is the chemical decomposition of a compound which takes place when an electric current is passed through either a solution or the molten form of the compound. So in electrolysis now, we are talking about chemical decomposition, that is the breaking down of a compound. We break down a compound chemically. That's what we mean by chemical decomposition. And then this can only take place, as decomposition will take place by the passage of electric current. When we pass electric current through a compound, we can break it down. We can cause what we refer to as the chemical decomposition. But that compound now may either be in solution, that is a liquid, maybe in water, or when we melt it, maybe in molten form of the compound. So when we talk about electrolysis now, we are talking about the decomposition, that is the breaking down of the compound by the passage of electric current, and the compound may either be in solution or in molten form, and that's exactly the meaning of electrolysis. So more so now in electrolysis now, we also use some certain terms which are in electrolysis, and it is important that you are aware or you are made aware of all these terms that are being used in electrolysis. To start with, we talk about electrolyte. That's one of the terms that are used in electrolysis. Electrolyte. Electrolyte is a compound that is either in solution or molten form which conducts electric current and is decomposed at the electrodes in the process. So we'll talk about electrolysis, that we are decomposing compound by the passage of electricity, and that compound may either be in solid, in molten form, or in liquid form. But when we talk about electrolyte now, we are talking about a compound which must be in solution or molten form, which we allow the passage of electricity, or which we conduct electric current, or is decomposed at the electrode in the process. We will talk about the meaning of the word electrode as we proceed in this program. But we are talking about the definition of electrolysis now. We said we have to do electrical decomposition of a compound in more solid or molten form or in solution. And we also talk about the electrolyte, that is liquid, that will allow the passage of electricity, and that will also conduct electricity. More so, another definition that we also words that we also use in electrolysis is that of electrode. What's the meaning of the word electrodes? Electrodes are conductors, poles of carbon or metals, through which an electric current enters or leaves the electrolyte. So in electrolysis now, we talk about the poles, the positive poles, the negative poles. So the electrodes are conductors, or referred to as poles. If it is positive, then the negative ion must move towards it. If it is a negative pole, then the positive ions must move towards it, because like charge will repel and the like charge will attract. And these poles now are either made up of carbon or metals, and it's through these poles that electricity will either enter or leave a liquid that will conduct electricity, which we refer to as electrolyte. So far, I hope you have been taking note of this. We define electrolysis. We talk about electrolyte, and we have talked about the poles that will also allow the passage of electricity, or through which an electric current either enters or leaves the electrolytes. Yeah, when I was talking about the electrode, I said that will be behind up having a positive pole or negative pole. But one of those poles is the one that we refer to as a anode. An anode is a positive electrode or a positive pole through which an electric current enters or leaves the electrolyte. So an anode is positive, is a positive electrode, and it's through this anode now that electric current will either enter or leave the electrolyte. And so indirectly now, anode is one of the electrode, but it's a positive electrode. So we also have another electrode, the one that we refer to as the cathode. But in this case now, unlike the anode, which is a positive electrode, the cathode is a negative electrode, by which the current leaves the electrolyte, or by which electrons enter the electrolyte. I hope you are taking note of the word. The current is leaving, and the electrons will enter into the electrode. So we have the negative electrode called the cathode. We also have the positive electrode called the anode. And the mathematics of this is this: the negative electrode now, which we refer to as the cathode, we only attract the positive ions, which are what we refer to as cations, and the negative, the positive electrode, which we call the anode, we attract negative ions. The positive electrode, which is the anode, we attract the negative ions. The negative electrode, which we refer to as cathode, we attract the positive ions. Like charge repels, unlike charge attracts. So based on this knowledge now of electrolysis, of electrode, of anode, of electrolytes, and of cathode, we can have what we refer to as electrolytic cell. An electrolytic cell is now made up of, consists of an electrolyte, and which is also made up of the electrode connected to a suitable direct current. You remember that when we were talking about electrolysis, we said that there will be passage of electricity through a conductor to break them down. We have to break down the compound into their individual ions. So in an electrolytic cells now, we need this electrolyte, we need ions for us, and then we also need a source of electricity that will assist in the breaking down of the compound into their individual ions. Now we come to the point where we need to talk about the ionic theory. When an electrolyte is melted or dissolved in water, some, if not all, the substance breaks up into freely moving charged particles called ions. What we are saying in the right sense of things is that when you have an electrolyte, for example, let's look at sodium chloride, which is the common salt. So when you dissolve sodium chloride, which is common salt, in the water, what you will notice is that is when we dissolve it in water, some of them, if not all of them, will break up into what we call freely moving charged particles called ion. So for example, in the case when you dissolve common salt, which is sodium chloride, in a beaker of water, it will break down to form two compounds, sodium ions as well as chloride ions. That's exactly what we mean by the fact that it will break up into freely moving charged particle. The sodium ion is positive because for metals, and the chloride ion is a negatively charged ion because from non-metal. So we're having two ions now. We're having the positive ions, we also have the negative ions, and this is very important. But we can only achieve this now because of the fact that we must have what we call electrolytic cells. In which case now those ions now, if we are having an electrolytic cells, each individual ions will at the end of the day move into the cell, the electrode that is having opposite charge to it. The positive ions move to the negative electrode. A negative ions will move to a positive electrode. And this process is also known as ionization. But what is ionization? It is the process of dissociation into ions. The process of dissociation into ion is also known as ionization. So the breaking down of the salts, the common salt, like I mentioned earlier on, into its individual ions is called ionization. That is, we have been dissociating the ions into the positive ions as well as the negative ion. And the process is called ionization of those ions. But ionization occurs before an electric current is passed into the electrolyte. This will take place before the passage of electric current. That is, once you dissolve the compound that is an electrolyte in the solution now, it will dissociate before the passage of electricity. And these ions now will move about at random in all directions because we are having those ions now being dissociated now. They move around in a random position because the direction is not focused. We don't have the passage of electricity. But at that point when an electric current is passed, the ions are attracted to the cathode. The positive ions are attracted to the cathodes, and these are known as the cations. The positive ions will move to the negative electrode, which is the cathode, and they are referred to as the cations, while the negative ions are attracted to the anode and are known as the anion. You remember what I mentioned earlier on? I said that we are going to have dissociation, in which case now the ions will break into their individual ions, the positive ions and negative ions, but they will be moving randomly in the solution
until the passage of electricity. But once we have the passage of electricity, the positive ions moves to the negative electrode, while the negative ions will move to the positive electrodes. So like I said, the negative ions are attracted to the anode and are called anions, while the positive ions are attracted to the cathode and are called cations, cathode ions, cation. And so the current through the electrolyte is carried by the movement of ions to the electrolyte. So by the passage of that electrolyte, current through the electrolyte, the current will pass by the movement of those ions. That current is being carried by the positive ions as well as the negative ions into the individual electrodes that are involved. So for example, let's say a metallic ion is derived from the atom by loss of a number of electrons equal to the valency of the metals. If you remember your basic knowledge of periodic table, you will remember that metals now will lose electron to achieve what we refer to as pseudo-noble gas structure. For example, in the case of sodium having one electron in its valency shell, it will lose one electron to achieve the pseudo-noble gas structure of the closest noble gas to it, which is neon. So you can see now in the case of metallic ions now, they will lose electrons, so they're losing electron to become unipositive sodium ion. Whereas in the case of lead, it needs to lose 2 electrons to attain pseudo-noble gas structure. So we have lead 2 ions. So a metallic ion is derived from the atom by the loss of a number of electrons, which is equals to the valency of the metal. The metal will lose electron, which is equals to its valency, to attain the pseudo-noble gas structure. And that, by attaining that pseudo-noble gas structure now, it is going to form its metallic ions. So in the case of metals, the loss of electron is important for metals to form their attain or form their ionic form. But in the case of non-metals, this is not the case. A non-metallic ion is formed from the atom by gain of electrons, which is equal in number to the valence of the atom. The non-metals will gain electron to achieve or attain pseudo-noble gas structure. So in the case of sulfur now, it is gaining 2 electrons, and then you have excess electron. Since electron is also negatively charged, you have an excess 2 electron being gained. And so non-metallic ions are formed by gain of electron, which is equals to the number of valence electrons that they need to attain the pseudo-noble gas structure. So today we have talked at length about so many things. We have talked about the metal. We started talking about the electrolytes, and we talked about the definition of electrolysis. We said that for electrolysis to occur now, there was a passage of electricity. We need to decompose the compound. We talked about electrolytes that are liquid that will allow or facilitate the passage of electricity in molten form or infused form. We talk about the electrodes. We said we have the positive electrodes. We also have the negative electrodes. We talk about the metallic ions, where we refer to as cations, because they move towards cathode, which is negatively charged. So since they are positively charged, they have to move to the negatively charged pole, which is the cathode. We talk about the non-metals, which are negatively charged but has to move to the positively charged ions. So we refer to them as anions. So we have the cations, we have the anions. And so we are talking at length about this, and we said that once we dissolve an electrolyte in the solution, the ion, it will decompose, but those ions will be moving randomly. It's only by the passage of electricity that those individual ions now will move into their different poles. So in details now, we need to go over what we have done today. To start with now, we said it that electrolytes are compound, which are either in solution or molten form, will conduct electricity. They will conduct electricity, they will allow the passage of electricity through them. We've also talked about the anode. We said anode are positive electrode. So since anode are positive electrode now, it is only negative ions that will move to it, because being it positive now, it needs an opposite charge to attract to it. And that's why we have non-metals that need to gain electron, be moved to the what? To the anode. And that's why we refer to the non-metals as the non-metallic ions as anions, anode ions, ions moving towards anode. We've also talked about the cathode, which is actually is a negative electrode, but it's attracting positive ions. And positive ions for metals. Metals will actually lose the valency electron to attain what we refer to as pseudo-noble gas structure. They will attain the pseudo-noble gas structure, and the negative electrode now will attract the metallic ions, which are positive ions. So that's exactly what happened. So we refer to those ions now as what we refer to as cations. But before we go now, I would also like you to take note of the assessment questions that you need to work on, and we'll be very happy if you can give us feedback on how you have been faring on in all this assessment that we have been giving you, and if you have been having any problem as it has to do with some of these assignments. For example, explain the meaning of the following. The word cation. You know, we'll talk about this. Anions, cathode, anode, electrolyte. All these are keywords that are very important in electrolysis. So from here now we could come to the end of today's episode of the program. I hope you are going to join us this same time, the same station, the next time, as we continue in this topic of electrolysis. From us in the studio, have a nice day.